Hello guys, welcome to the session. Today I am going to tell you about the differentiator in op-amp. Today my topic is differentiator in op-amp. Let's see, the title is differentiator and the definition of the differentiator is a differentiator is a circuit produces the output voltage that is proportional to rate of change of input voltage. Here see the diagram of differentiator. In differentiator diagram, let's see, in this diagram the input voltage is V in and the input current is I in and capacitor C and BC is the voltage across the capacitor. Then X is the point. Here we have the voltage V. Assume the voltage here at point X is VA. Then we have feedback in op-amp. This feedback we have RF, feedback resistance. RF is the feedback resistance and IF is the feedback current. Then we have Vout. Vout is the output voltage. V in is the input voltage and Vout is the output voltage. This is the diagram of differentiator in op-amp. Let's see the output voltage of differentiator. Output voltage. The output voltage of differentiator is V0 is equal to minus RF C d by dt into V in. That is output voltage V0 is equal to minus RF C derivative of V in. V0 is output voltage, RF is feedback resistance, C is capacitance, V in is input voltage. This is the formula for the output voltage of differentiator. Now see the derivation of output voltage of differentiator. First of all, assume given op-amp is ideal, so no current is flowing through this op-amp. See this op-amp is ideal, so no current is flowing through this op-amp. From this point to this point, no current is flowing through this op-amp due to this op-amp is ideal. Next, see at node VA at point X, the node VA acts as virtual ground, so VA is equal to 0, then VB is equal to 0. Here at point VA at point X we have voltage VA and here we have voltage VB. Here at point X we have voltage VA, at here VA at node VA acts as virtual ground, so VA is equal to 0 and VB is equal to 0. Then apply KCL, Kirchhoff's current law at VA. At VA, that means here VA at point X we have VA, at node VA apply KCL, Kirchhoff current law. The current is I in, that is flowing through this branch from here to here. So at point VA at node VA, I in is equal to IF by KCL. Here I in is equal to IC. IC is the capacitive current. So by applying KCL we have I in is equal to IF. So by applying KCL, Kirchhoff's current law at VA we have I in is equal to IF. We have the formula that for current I is equal to C into d by dt into V. So I in terms of current in terms of capacitor we have I is equal to C into d by dt into voltage. In this branch we have voltage V in minus VA. In this branch the voltage is V in minus VA. So we have current I in is equal to C into d by dt into V in minus VA. That is the input current. Input current I in is equal to C into d by dt V in minus VA is equal to IF is the feedback current. In feedback path we have voltage, we have resistance, that is feedback resistance RF. So by Ohm's law we have I is equal to V by R. So in feedback we have RF, so voltage is VA minus V out. So I is equal to V by R. So IF is equal to VA minus V out by RF. V out is equal to V naught. So here IF is equal to VA minus V naught by RF. So IF is equal to VA minus V naught by RF. So at node VA acts as virtual ground. So VA is equal to 0. We know that. So C is equal to C into d by dt V in minus 0 is equal to 0 minus V naught by RF. We know that VA is equal to 0. Substitute VA is equal to 0 here. We get C into d by dt V in minus 0 is equal to C 0 minus V naught by RF. So from this equation we get V naught is equal to minus RF C d by dt V in, that is output voltage we get. In this way we have to derive the output voltage of differentiator. Now see the input and output waveforms of differentiator. If we give input is sine wave, then we get output as minus cosine wave. This is the input and output waveforms of differentiator. If we give sine wave, we get minus cosine wave. We have to understand this by output voltage formula. If we give input voltage as sine wave, that is V in is equal to sine theta, d by dt of sine theta is cos theta. Then we get minus cos theta as output voltage. RF and C is constant. So V naught is equal to minus cos theta, that is V naught is equal to minus cosine wave we get. So output voltage is cosine wave if we give input as sine wave. If we give DC input to the differentiator, we get output as 0. Let's see how. DC is the direct current, that is constant. DC is constant. So C in this formula, V in is constant, that is V in we give as DC, that is constant. D by dt of constant is equal to 0. 0 into something is 0, so we get output voltage as 0. So if we give input is DC, then we get output as 0. So if you give input is DC, then you get output as 0. This is the input and output waveforms of differentiator. By giving input sine wave and DC input. Now see the frequency response of differentiator. This is the frequency response of differentiator. The y-axis we take as gain, then x-axis we take as frequency. This is the frequency response of differentiator. Here we see V out is output voltage. We have formula V out is equal to minus RF by XC into V in. We know that XC is equal to 1 by 2 pi FC. XC is the capacitive reactance. So this V in is, when this V in is going to this side, we get V out by V in is equal to minus RF by XC is equal to, XC is equal to 1 by 2 pi FC, then 1 by XC is equal to 2 pi FC, then 1 by minus RF by XC as taken as minus RF into 1 by XC, then we get minus RF into 2 pi FC is equal to A is the gain. We know that gain is output voltage by input voltage. So here V out by V in is the output voltage by input voltage. So that is gain A is equal to minus 2 pi FC RF. So A is the gain. A is equal to minus 2 pi FC into RF. So here C is constant, RF is constant, pi is constant, 2 is constant. So A is directly proportional to F, that is A is equal to gain and F is equal to frequency. So gain is proportional to frequency. If A increases, then frequency F also increases. That means gain A increases, then frequency F also increases. If A is equal to 1, that is if gain is equal to 1, then we get F is equal to minus 1 2 pi Rf into C. Let's see how it is. A is equal to 1, put A is the gain, we know that. So put A is equal to 1 in this equation. In this equation, then we get F is equal to 1 by 2 pi Rf into C. Now let's see the applications of differentiator. We have the applications of differentiator. They are cruise control systems in cars for maintaining constant speed. We are using this differentiator in cars for maintaining constant speed. Then we have biomedical signal monitoring. That is, op-amp can magnify biology signals to increase them for better monitoring. We are using this differentiator as biomedical signal monitoring. That is, this is the op-amp. We know that op-amp is a device. So differentiator we use it in as biomedical signal monitoring. So for better monitoring, to improve the signals, we have used this differentiator. We know that op-amp is a device to improve the signals, to amplify the signals. So here we use it for cars, and we use it in cars and biomedical signal monitoring. These are the applications of differentiator. Thank you guys. In, in this way I have conclude my session. Thank you for watching. Thank you guys. Have a nice day.